OptiLayer Monitor is a program designed for monitoring the deposition process of multilayer interference optical filters. This program is a key part of the OptiLayer software package. The OptiMonitor interface aligns perfectly with the entire ecosystem of the OptiLayer hardware and software complex, which significantly simplifies operation. Thanks to this unified architecture, there is now no need to use special formats to transfer the necessary coding information to the process control system. OptiMonitor allows you to transfer the entire project, which contains information about the design of the optical structure, meaning the number of layers, the thickness of each layer, and the film-forming material for each specific layer, as well as information about the substrate thickness, the substrate's optical constants, and the refractive indices and absorption coefficients of the film-forming materials used. Because a project in OptiMonitor is identical to a project in OptiLayer, you can now use multiple designs within a single project. There is absolutely no need to create several projects for depositing a specific optical structure. Switching between designs or film-forming materials takes just 2 mouse clicks. Thanks to the unification of the interface and project architecture, it is now possible to make minor adjustments to the optical design directly within the project if necessary, without the need to create a new one. Furthermore, this unification enables the rapid exchange of information between all components of the OptiLayer software and hardware complex, such as OptiLayer, OptiRE, and OptiChar. This allows for quick reverse engineering or more in-depth adjustments of key parameters for optimization, such as refining the optical constants of film-forming materials or fine-tuning the optical design using optimization algorithms. Even though OptiMonitor does not require a specialized format for data exchange, for older or legacy projects, there is an option to load data into OptiLayer Monitor using the export function for files in the .lmr or labeled monitoring report format. This format is used in OptiLayer CAD software and does not require any additional conversion. OptiLayer Monitor communicates directly with the control system's equipment and is able to identify the dark background signal, the lamp signal, and the witness signal. This identification can be done either by using an encoder or algorithmically, based on the characteristics of the raw signal series. The first window shows how the program identifies the raw signal values. In the second window, a dynamic diagram is constructed to help visually determine the classification parameters. The third window allows you to evaluate the raw signal profile and set the calibration parameters. An important feature of OptiMonitor is the ability to perform both broadband monitoring and monochromatic monitoring simultaneously. Furthermore, during the deposition process, the user has the option to manually adjust the monitoring wavelength in real time. Before starting the deposition process for the optical structure, the user can configure the process parameters. These include 1. Polarization of the radiation. 2. The spectral range in which process control will be performed. 3. The type of input data, reflection or transmission. 4. The angle of radiation passage through the substrate. 5. Substrate thickness, with or without consideration of backside reflection. 6. The spectral range in which optical structure reoptimization will be conducted. And 7. Setting the lead time for shutter closure. During the deposition of the optical structure, the user can perform real-time visual monitoring of the process. This window shows how the actual spectral characteristics change during the deposition of the layers. For convenience, several spectral curves are displayed on this screen. More details about the purpose of these lines are written in the manual for this software. In this window, the user can view the main information about the current state of the process. This includes the number of the layer being deposited, the target thickness of the layer, the thickness already deposited, the material deposition rate on the substrate, the film-forming material of the current layer, and the estimated remaining time until the layer is completed. The user also has the ability to manually control the stopping of a layer if necessary. As the layer approaches its completion point, the stop button becomes highlighted, informing the operator that it will soon be time to finish the layer. Every performed process is automatically saved in a database as multi-measurement data. This allows for the quick loading of the spectral characteristics obtained at the end of each layer during deposition into the OptiLayer software package for a detailed study of errors in the deposited layers. It is important to note that even processes that, for whatever reason, were not completed are saved. If a large number of processes have been conducted within a project, the user can download data about a specific process from the history. This program also provides a powerful simulation capability. Simulation allows for modeling the conditions under which the optical structure will be deposited. In the Simulation Settings window, the user first configures the parameters for the material sputtering process. Next, the user defines the spectrometer parameters. Finally, the user can set the expected errors in the signal obtained from the spectrometer. After applying these parameters, the user can run the simulation process, which you can observe on the screen now. Just like in a real deposition, simulation is available for both broadband and monochromatic control,